Hi everyone, welcome back. In this video, I am going to talk about Args and hyperparameter organization, which is a very simple topic, but it can be extremely effective in expediting your implementation and training. The first thing is obviously what we know that what are arguments, like the different arguments that you have to use for your Python code or your project, like the path to your model or the path to your dataset or other arguments, the number of GPUs that are available on your system, and hyperparameters for your model, for your neural network model, are like learning rate or the batch size or the number of epochs. So these are the hyperparameters on Args, and they will show up in your code frequently. For instance, a simple machine learning project has many hyperparameters that you need to optimize them. You have to manually find the best set of hyperparameters. So what are the necessity of, so let's go to the code that I have here and discuss some of them. So these are my these are my arguments that I have organized all of them in one single place that is later called args. So if I later anywhere in my code want to get access to my arguments, I can just type args dot the name of that argument. For instance, args dot job name or learning rate or anything. Args dot the name of that argument. So these are the arguments that I have. And what would be the necessity, the second thing that we needed to talk about? The necessity of factoring out and putting them in one place, in one object called args, and organizing them all in one place is that if you scatter all of these hyperparameters along your code, it is difficult to find them and change them, and making sure that you haven't introduced any bug while you were changing that learning rate in line, for instance, 700. And also it is and also so this was the first point. The second point is that when you are training your machine learning project, you have to adjust the learning hyperparameters, and you have to manually, with grid search or any other method, find the best set of hyperparameters. For this purpose, you have to run multiple experiments. For instance, this is batch size and learning rate. We want to find the best combination of batch size and learning rate. What would be the best value of batch size and learning rate that our model perform better? So you have to, in this case, that you have three different values that you think they are going to probably the best learning rate is in this range. You will pick three values, 1, 2, 3, and you also have three different batch sizes. For instance, 3 or 16 or 64. So you run the first experiment, the second experiment with fixing the batch size but varying the learning rate. You do so with the second batch size and also with the last one. So here that we only pick 2 hyperparameters, we ended up with 9 experiments. So in your code, in your real project, that you will definitely have many hyperparameters and you have to run many experiments, you have to change the values. This is your Python code. But we know that for changing those, your project.python, we know that for running different experiments, you only need to change this one single line here, the value of learning rate or value of batch size. But this is not true. let me erase that. We have already discussed that we have factored out all of the hyperparameters and uh, arguments in one place. So let me type them clearly and closely together at the top of the code. LR equal some value and batch size equal, for instance, 8. So if you want to run experiment, you need to change these values, but we don't want to touch our Python code. The Python code is pretty much the same. We want to pass from the outside when we are running our Python code project. So the first option for running experiments is going into your Python code uh, and changing these values to something else, for instance 0.7 and 82, and then run this line project.python python python project.py. But we don't want to change our Python code because we will end up with countless Python files that are pretty much the same. So what would be the alternative? The alternative is having Args that is handling that for you, which is taking the value of the hyperparameters, the arguments outside of the Python code, and it will pass them and redirect them to your Python project, and your Python project.py is able to find those values and change them by the default value that you had here, by the default value that you had here. Um, here. So the way that you can do that is by using dash dash the name of that LR, and then you pass the value that you want, or batch size, then the value that you want to pass. So this is definitely better than changing your Python code and ending up with countless Python codes that are pretty much the same. So this was the necessity. I introduced you to two different necessities. There are many others, but that would suffice for now. All right. Now that we know the necessity, the other parts are pretty much simple and about the syntax. So how you can organize your arguments in one place. For doing so, you have a object called argument parser, and you initialize that, and then later you add different arguments to that. For instance, I add learning rate or learning rate scheduler with their default values if I want to pass any default value. And also there are some arguments that they are true false, they are binary. So if you pass debug, the value of debug will turn to true. The action for that is store true if I pass dash dash debug. And then later, once you are done with the defining the arguments, we pass the args object. We call parse arguments, and then we return the args object. Args objects right now contains, when we pass that, contains the value of all of those arguments. So this was the third part, and the fourth part is, okay, so let's go and run some codes. So this was our test args Python code that has a function that factor out all the arguments and hyperparameters in our code and put them in one place, and later when we call that function prepare args, the prepare args come here and create one argument parser and add the different arguments that we have here, and later call parse arg. parse arg will go into the CLI into the command line and see what did we pass and put the values inside instead of the default values. If we didn't pass any value, it will use the default value, and later we will pass the object, args object, that contains all of the keys and values, and you can access to the value by either, in this case, args dot the name of your args, for instance args dot batch size, or you can print them like the way that I have printed them here. Alright, so let's run Python test args dash dash, or let's don't pass anything to that and run that. Okay, if you run that, you will see that one log file has showed up here. When you open that log file, we will have the key and also the values for all of our arguments. Why? Because in our code I had one function, print args, and I called that after calling prepare args function. These are other setups and also global variables that I had in my actual thesis project, but right now I have removed the other parts because we want to concentrate on args and not anything else. So alright, so this was the log file that we had. Let's pass something. Let's run the command again and pass dash dash lr 0.2 and run that again. So as we can see, the value of LR learning rate hasn't been changed. Interesting. Why? Python LR dash LR. Was it the previous? Is this the previous log file? Let me close all of them. Oh, we didn't save the LR. The default value is this. Okay, let me run that again. I think we didn't delete the previous log file. Permanently delete, yes. Git bash here, Python test args dash dash lr 0.2. Alright, as you can see, the learning rate has been changed from its default value to 0.2. Alright, so this is the way that you can pass the values without touching your Python code, and it is very convenient, and it will 10x your experiments and your work speed. And that's pretty much about it. The next point is about running your code on Google Colab cells. So imagine that you have implemented your code and you want to run that on Google Colab. You just come here and print them here. If you run the same thing or the same code here, you will get a bunch of errors, and the reason is you are not directly calling your function, your Python code from terminal. There is one intermediate process here, this Google Colab cell, which confuses our function, which confuses our parse arg function. So in order to handle that, I have implemented a utility here that you can, if you are running the code on Google Colab, you can pass running on notebook true, and then you pass the args, the default value that you were about to pass, in a list. So let's do that here and run the code again. So this is the place that I'm passing through, and then let's do the same. Let's pass the same args that we passed before, 0.2 for learning rate, and then run the code again. Yeah, it ran the code successfully, and we have the log file here, which contains 0.2 as for the learning rate. And as you can see, guys, I have I'm printing all the values in a log file. Why? Because I have initialized and set up a log file by this line here. And this is the best practice that you can do instead of just going and printing the values. This is not recommended, especially, so if I just print the values here, instead of printing the values in a log file, it will print them in terminal. So let's do that. Python test -lr 0.2. It will print them in terminal. But you want to, especially when you are training your file, you want to log the different values. You want to log the value for your F1 score, or when you're training, or the value for your accuracy as you are training, or the loss value. So it is very convenient to have all of them in one place, so that later you can refer to that, and many other benefits that this best practice has. So I think we covered all the contents. If you have any questions, please feel free to comment below. I will definitely get to them as soon as possible. And also, if you enjoyed this video, leave a comment, thumbs up, and share that with your friends. And take care. See you.